Hello, welcome to Lab 10, and this is titled Proteins and the Isolation of Caesium. In this lab, we're going to learn to understand protein structures. I teach a lot of biochemistry here at Channel Islands, so protein is the backbone of the biochemistry discipline. We're going to learn about denaturing of proteins, and we'll see different ways that we denature protein. And we're going to isolate and determine the percent mass from milk. And it's the percent mass of protein. As you can see, I'm in a laboratory. For good laboratory purposes, we wear a lab jacket. I will be wearing safety glasses as an important precaution, along with gloves. In addition to that, I have closed-toed shoes on, and I have long pants on, all protection for the skills that we have to do. And of course, I have a mask to protect me as a result from COVID that we do. So let's get started, as I have all my equipment on, and my equipment's ready to go. So I'll see you over in the lab. As you can see here, I have 5 test tubes, which is what we'll need for our experiment. Our first step is to make sure to label these test tubes with the tests that we're going to be doing. So I'm going to label them test tube 1, 2, 3, 4, and 5. 1, 2, 3, 4, 5. The second step in our procedure is to place 3 milliliters of 1% egg albumin mixture into each test tube. What I have here is my 1% egg albumin mixture. And to get 3 milliliters accurately in, there's 2 ways that we can think about it. Here, I have a very small graduated cylinder. It goes from 1 to 10 milliliters on it. And so I can place 3 milliliters in there. The other way is to use a pipette. And this pipette is rated for 0 to 1 milliliter. And I tend to go, when I'm dealing with proteins, with the pipette method. Mainly because you'll see that proteins have a lot of bubbles. If you've ever done egg whites, you're used to the bubbles. And when in a graduated cylinder, sometimes it can be a little bit difficult to see the graduations if there's bubble involved. So in this case, I have 1 milliliter or 1,000, 1 milliliter pipetter. So I'm going to be pipetting 3 milliliters or pipetting 1 milliliters into each of my 5 test tubes. Now that we have our test tubes filled, let's make our first observation. And that is what the albumin looks like before we've treated it with anything. We are going to be treating it with 5 different ways, and then making our observation as to the changes that it's gone through. The first test tube that we're going to treat is heat treating. And your manual talks about holding it over a hot plate. Instead of doing that, I have a hot plate heated here. It's heated to boiling. I turned it down just a minute ago because it was boiling rapidly. What I'm going to do is to place test tube 1 into the boiling water. We'll hold it there while we do the other experiments, and then we'll do a post-observation with test tube 1. So this is test tube 1. It's going into boiling water on my hot plate. We'll let it sit there as we do test our other test tubes with different environments. Into test tube number 2, we are going to be putting nitric acid. So here's a 10% nitric acid solution, and we will be putting 2 milliliters into the test tube. So again, here's our observation of test tube number 2, our before. Here's my nitric acid. And again, I'll be using the pipette method to transfer the nitric acid. Here's 1 milliliter and 2 milliliters. And here's what test tube 2 looks like with the nitric acid added. So again, we can see test tube 2 versus untreated, which is our test tube 3 here. Into test tube 3, we are going to be adding sodium hydroxide. And here's a 10% sodium hydroxide solution. And we will be putting, again, 2 milliliters into test tube number 3. I move test tube 2 over so we don't confuse it. Here's our test tube 3. Oops. Common. And here's what our test tube 3 looks like after our addition of sodium hydroxide. Here's an untreated and here's a treated. I could put a white sheet of paper in front of that, but what you're seeing is a clear solution. Shake that flag. Heat treated one a little as we're doing the rest of our experiments. For step number 6, into test tube number 4, we're going to be putting 4 milliliters of ethanol. Here's my ethanol solution. And it is, in this case, denatured ethanol. This is 100% versus the 95%. It's in your lab manual. So again, I'll move test tube 3 over so we don't have to worry about mixing it in. Put a clean pipette tip in. Make sure it's secure this time. Take a look at it. Shake it up. And if you can see within there, hard to see close in the camera, what I'm seeing are bubbles coming up. So some gas was being released from our solution. And from those bubbles, we're getting a relatively clear solution. So if we look at number 3 versus number 4, again, we have semi-clear solutions for both of them. The difference being with 4, I did observe bubbles coming up as part of it. So let's look at number 5. With number 5, I'm going to be adding 10 drops of silver 1 nitrate into 5. Shake up my heated one a little bit. Get my silver nitrate, my silver 1 nitrate. So 1%. I will be using a dropper this time versus my pipette. So they want 10 drops. One, 2, 3, 4, 5, 6, 7, 8, 9, 10. Shake it up a little. And what do you see? Again, it's a white precipitate, similar to what we saw with test tube number 2. If we look at test tube 2 versus test tube 1, we're seeing a similar white precipitate. I'm not observing any gas coming out as we did in test tube number 4. Let's go back to our heat treated one. This has been in boiling water now. Interesting, we have some white particles. Do you see the white particle in there? Kind of looks like what an egg white would look like if it got heated up. So I'm seeing some white particles there. I see also some particles or white substances on the side where it got heated as a result of that. So a nice little chunk in there. There also appears to be a little bit of stringy matter. The bubbles have some additional strings that are associated with them. So there are our 5 test tubes and what we've done to show differences in protein behavior. We used heat in test tube number 1. In test tube number 2, we used nitric acid. And again, we see a white changing from the clear to the white. In test tube number 3, we put sodium hydroxide. What we got is a clear solution. I didn't observe any bubbles as it went into it. Test tube number 4, we put in ethanol. The ethanol, I saw a lot of bubbling occurring with it, and then we ended up with a clear solution. Finally, in test tube number 5, we put in silver nitrate, silver 1 nitrate, and we get a thick, milky looking solution with it. Hi, it's me again, not just my hands working. In the second part of the experiment, we are going to be isolating caesium from milk. So let's join me as we first start at the scales. So we're going to start the experiment by weighing out or measuring out 20 milliliters of milk. But we want to know the weight of that milk so that we can do a weight before or after when we do our precipitation reaction. So I'm going to start with a 50 milliliter beaker. And I'm going to go ahead and put it on a scale and tare that scale. Tearing the scale zeros it. So we now have our scale set at 0. I am then going to measure out and put in 20 milliliters of milk into it. And here you see a beaker, the beaker that I'm going to be putting my milk into, and a graduated cylinder that I'll be using for measuring my milk out. And I want 20 milliliters